Thankfully, I finally fixed that, so we're not seeing that anymore. It is 8:04, so I'm gonna give it a few more minutes. I'm gonna grab a coffee, and then we'll get started. So, yeah, just wondering, where is everyone with the course contents? I mean, I I do believe I have an option to check, but I thought I'd just ask you guys instead.
I have not done assignment 3 yet.
Mm-hmm.
Also stuck on assignment 3.
Okay, but the other ones are done then. That's great. That's fantastic. Right. I'm not sure if anyone else will come today, but since it's the last session, we'll give it a few more minutes. So, as you guys may have noticed, like this session, as I mentioned, is thankfully a little bit light for us because we already covered lists before. We'll go over them again. But yeah, I mean, it turns out for some reason no one else had covered lists. But okay, yeah. So we're done with lists, right? I mean, you guys remember lists? I'm just kidding. We will do it.
Yeah.
Here, but yeah. Oh, also, someone introduced me on the teaching team recently to an amazing video about how you should feel when your Python code isn't working. Which pretty much makes sense. But yeah, I mean, that aside.
I like it.
Excellent. Charlie, I don't know if you have been with us before when we covered the workspaces. So Abraham and Sean, you guys are comfortable with the workspaces before. Charlie, have you been on the workspace before? No, right? Have you opened the link?
Yeah. I just opened the link.
Okay.
I haven't worked with that before, so but I opened the link.
Okay, fantastic. So the way it works is quite simple. You can just start typing and we'll all be able to work with this together in lifetime. So if you open, say, index game, like so, you double click on it, then you can start typing, and all of us can really together. So yeah. I find it insane that at the end of like 5 weeks, when I finally got rid of the black background, I have now lost my face. But okay, it's okay. Just a few more minutes. I suppose we'll get started at 8:10, whether someone comes or not. But this is great. I mean, it's great to see you guys, and it's really neat that like you guys have been doing the assignments. So yeah, awesome. Oh, so have you guys been told yet about what's going on next week? Do you guys have any idea yet, or should I give you spoilers?
No idea.
There's a short video, but not too much said.
Ah, okay, right. So spoiler, all the section leaders, like not just me, but like there are a bunch of these sessions which are being planned at 9 a.m. and 9 p.m. PDT, apparently. And they're like ask me anything sessions. So all the section leaders will be talking about what they do. There'll be like, I think 2-minute long videos about what they do and what they're doing with their life and code. And then you can ask them anything about it. So they're in groups of 4. And I'm sure someone will officially explain this to you guys a lot better than me. But yeah, I mean, there's something to look forward to. Also, before we get started with the content, I've been thinking, what have you guys thought about for your final project?
I have not thought about it yet.
Okay, so as you may already know, that this is technically the last section that leading class thing which we have, right? But I've been thinking about it, and once you guys have made a project, then it sucks if you can't show it off, right? So I was thinking maybe next week we'd have an extra session where I would just sit back and let you guys present your projects, and you can discuss your process, and nothing major, very informal. You don't need to make slides or anything. But yeah, I mean, if you guys want, we could do that.
Yeah, that sounds good to me.
Awesome. Okay, I also just downloaded another Zoom client, so I'm gonna give that a shot. So if not, I will rejoin with, yeah, no, we're good. Forget about that. Okay, so let's do this. Let's get started with.
Just wanted to say that in about 1 hour, I will have to leave.
Sorry, I don't think I got that.
In 1 hour, I'll have to leave.
Oh, okay, great. Yeah. So let's get
just so you know.
Yeah, fantastic. Yeah, that's great. Right, so this is the section handout. Now there are two ways we can do this, because for some reason this wasn't working last week, but this week we have this lesson space as well, but that's not really a lot of fun. So let's just play around here. Right. So have you guys gone through the section handout yet? Okay, excellent. Let's do this together. So, okay, so first of all, let's start with a much more general thing. What is a file? Like ideas? Okay, let's start again. These are all files, yes, or representations of files. And in fact, very familiarly, when we work with the command line, then it's clear that we have a lot of files. I do have a lot of files here. I don't know why. Okay, cool. So these are all files, but what does that really mean, right? I mean, and clearly some files are easier to understand than the others, right? Let's say we go to, yeah, so if we know that, say, CS words is a file, then we can check what is inside that file, right? Something or the other, lots of content. But you'll remember from last time that not all files are this nice, right? I mean, if we try doing the same thing, if we try outputting to the standard output, say a BPDX, then very bad things are going to happen. And in fact, it's just gonna, yeah, this happens, right? But the very fact that there is this kind of representation of the file should give you a hint about what exactly a file is. Oh, and also another plug. I recently just found out that there's this thing called Jamboard, which allows us all to scribble. So I have sent that. I see one person is here. It'll be great if everyone else, I'll just send it on the chat here as well. Although you can also find it the way I found it. If you go to, I updated this post. So this Jamboard link. The reason is because while it's a lot of fun to draw, it's even neater if all of you guys draw too, right? So this is a file. And really, so the fun thing about working in Linux is that it makes something abundantly clear. And that something is everything is a file. Okay, like literally everything. Anything that you look at is some sort of file. So let's do that. So, but before that, yeah, okay. What are the things that you feel might not be a file, or like, what is your understanding of a file? And remember, until now, we have, what is our understanding of a program, for example? We understand that a program has a space, right? And in that space, we have different functions. We have main, we have other functions, we have variables, we have global, whatever, right? So with this understanding of memory, and remember, memory is just a hardware thing, right? That's there everywhere. How do you think files work? Like, what is this guy? And in fact, give your best shot. I mean, try drawing your best shot, right? I mean, that would be awesome too.
Is it the storage place for all the information?
Right. So that is an interesting outlook. So you're saying that this basically represents storage, right? And
Yeah.
so when you say this, were you saying something?
I was going to say like the luggage. They're talking about how each luggage has its own tag or something.
Exactly. Fantastic. Yes, that is actually a brilliant way of getting this concept across. And the idea is, what Abraham mentioned, is remember how when we discussed variables, we said, hey, variables are like, these little luggage boxes, and you have like types and you have different things attached to it. Well, it so turns out that at the basic understanding level of the computer, it's all the same, right? So to the computer, this is also just a bunch of binary data, zeros and ones in a particular place with some extra features, describing that. So, and when I mean extra features, this is really called an encoding. It's not really very important to know right now, but just remember that when you see those fidgety sort of like those weird symbols we were getting on the terminal, right? Those actually are just in a different language. You can think about it as being in a different language, and that language is read by other things. So for example, a PDF which has that kind of shitty representation of just junk is actually something else, right? I mean, clearly these PDFs have data, and that's why we need special files and programs to read them, right? But the important takeaway here is that files are just blobs in memory, right? And how long they persist is when you start talking about storage space and RAM. So when we run programs, we talk about program memory and we talk about exhausting it, but we also inherently understand that, and what I mean by programs and memory is that you'll remember integers take up some space, strings take up a larger space, right? I mean, we remember all that. Inherently, when we think about this model, then we also think about reusing this, right? I mean, and in fact, that's when we talked about by reference and by value. Remember, when we move these around and we move their values around, we move their references around, right? So the only difference is, the one and only difference is, when we talk about these stores, when we talk about these file objects, then they get stored to permanent places in memory. Well, relatively more permanent, right? In the sense that when you have a file, you don't expect it to suddenly disappear, right? So, okay, so with that understanding then, what can we do with files? And in fact, this is something which we kind of already know, don't we? Because we worked with images before, right? And an image is a kind of file, and it's actually quite a special kind of file because it displays, it has, we discussed how images have pixels and 3 different color channels, remember? Actually, bonus, if anyone can draw, if Sean or Abraham can draw for me the 2 descriptions of images in terms of pixels, like the pixel object version and the, I mean, when I say bonus points, there are no points, there are no winners, but yeah, I mean, just to recapitulate. If you could do it here, that would be great. So we're on slide frame 2 of this Jamboard thing. Or is anyone drawing on?
So you're saying images? There's 2 types. Sorry, can you elaborate?
So do you remember we talked about images as a bunch of pixel objects in this representation? And yeah, perfect, yeah. And the other representation is in, Abraham's going for it, awesome. is in groups, yes. So you'll remember that we discussed that like there's positional. That's perfect. Thank you. So since Charlie wasn't there, I'll just quickly cover this again. Like so we discussed how an image is composed of pixels, and so essentially that means we have this kind of object which is x and y, so that we know where we are, and then colors, which is red, green, and blue, right? And so if you look at it this way, then you can think about each of these being in a grid, right? And each of these things with an x and y specified, this is say x, and this is y, becomes, you know, an image file. And similarly, there's another way of looking at this. We just say, okay, I have this thing called a pixel, which automatically knows its own x and y, and then is just a bunch of these objects. So we actually then are already working with files, right? I mean, which means that takes quite a bit of magic out of this, but we'll have some fun things to do still. Okay, so with that, let's take a look. Read the code and play the game a few times. Yes, okay, yeah, we're supposed to play a game today. Okay, does anyone remember what to do with lists? Or let me put it in another way. Let us open a new thing for just playing around with lists. List.py. I will copy parts of this. You see this? I'm trying to type and I can't. Wonderful. Sorry about that. Okay. Clearly, I'm having some issues. Fantastic. This is truly fantastic. Okay, fine, finally, we're back. So, does anyone want to fill out the basics we need to start printing things in this? You know, we just want to play around with printing stuff. So we need a main, and we need the little initialization in list.py. Meanwhile, I'll fix data science.py. Fantastic. Perfect. Okay, so now we want a list. So for that, I am going to quickly offload to some slides, which another fantastic section leader has made. So, you know, a list is a way of collecting ordered collections of items. Now, when we talk about ordered collections of items, then we recognize that, okay, so we have this data structure, right? And we want to address these bit by bit. So let's be more concrete. Okay, so let's say X is a list. A list is defined by having these little thingies, right? The brackets. And inside the brackets, we can put in Python, which is not true of other things, you can put whatever you want, okay? So this then is just a list. And let's see if that's true. Oh, we have to do something. Let's print. Okay. So this is what we get. But there are more interesting things about this. I mean, yeah, I mean, there are obviously more interesting things, but we already have seen much of this last time when we were querying different pixels, remember? Then those were lists too. And the real reason why, like, I'm not talking too much about lists this time is because those were actually much more complicated lists than just having, you know, these sort of single valued things. But it is still important to cover some basics. And the basics are just like the image objects we dealt with last week, these do have some inbuilt functions, okay? And one of them is called append. And so append is essentially, does exactly what it says. And that is, it just adds to the list. So yeah, and that's basically one of the very few things that you actually need to know about lists. Okay, yes. Now, because we covered this early on, the idea is to connect this to what we know now. Can someone write some code to show me what type is there for the first element and the third element? And does that make sense? And what type is X itself? So in fact, because I started with 3 elements, let's each take one. So Sean, you print out the type of one, the first element, Abraham second element, and Charlie third element. Cool? Let's go for that. So the idea is to query what the list thinks of it, right? So we don't want to enforce the type, right, Abraham?
Oh.
And I'll do one myself, which is print Right, so let's run this guy. Okay, any expectations of what we should get? I'm actually interested. So, you might understand or you might have guessed that like, okay, first will be a float, maybe this will be an integer, and maybe this is a string, right? Those sound normal. What about X? Any ideas about what X should be?
Will it be a variable?
So we don't actually, type gives us the type of variable. Definitely X is a variable, but what type of variable should it be?
I'm not sure.
List?
Yes, actually. And let's see. Yep, it's a list. So this requires a little bit of thought, although much of this thought we did last time. Remember, we looked at simple image and we were super happy when we saw that there were class pixels in it. And the behind the scenes story is, in Python, every single class which you define, and to go back to that, so what is a class and why do we care? So when we define a class, then we define certain things about it, like we can give it initializations, like in the image example, it is X and Y, right? And the image. And then we gave it certain properties, like last time it was get RGB, right? Or something like that. I don't fully recall, but I remember we were querying this. And the idea is, once we've defined this, then we can make any number of these, right? So we have 1 of these things, 2 of these things, 3 of these things. They're all of type pixel. So what that basically means is a list is just, like, there's no need to think of lists as especially magic. It is just a class which has been defined in the Python standard library. It's just a free class, right? So that's actually almost it for these, but there's still a little bit more. And the first thing is that the index game is actually playable. So who wants to type it and play the game? Go for it. Like, can you?
I'm still confused.
Can you guys type here? Like, you know, in the terminal?
Well, I'm still confused. Like I'm not sure what we're supposed to be doing.
Oh yeah. So there's this program, index game, which was already written for us. It's in the section handout, and we just have to run it. And when we run it, then it asks us to tell it who is in index one. And the concept we're trying to understand here is, what is the indexing of list elements? Does it start from 0? Does it start from 1?
Yeah, I was confused. There's the top right to open the terminal. It was closed initially, so that might help too.
Okay. Right.
I could try playing first.
Go for it. Okay.
Oh, cool.
And does it always ask about 1? Okay, no, now it's asking 4. But okay, basic arithmetic is all well and good, but like, you know. We'll take 2 seconds to go over this code, but I mean, correct me if I'm wrong. Is there anything we don't understand here? We know import random, right? We have defined a list. Okay, just for future reference, typically in Python, it doesn't matter, but in other languages, when you use like double commas like this, like, you know, this versus this is slightly different. But in Python, they're all one and the same. So let's not even deal with that. Then this is append, which we discussed, and append will insert it at the end. That's important to remember. It's also important to remember because that means when you add things to a list, then you only add it at the back, and then you have to do a lot more. It takes a lot more effort to move things around in a list than you might expect. So yeah, in fact, it's kind of ugly. So yeah, right. Anyone confused about any part of this code? Bigger. Oh, okay. Right. I see we have 10 minutes left. So, well, okay, fine. And I also know that Charlie has to leave soon. So let's quickly rush through. Well, I mean, not rush through, but okay, we can do this. Sure. Yeah, let's get this over with, and then we'll come back to some other things. And what we're doing is the game called Heads Up. The thing to do is, let's read through it. Yeah, so we want to read data from files. We want to load data from a file. And clearly that is something we need to do in life. And it does things. We will play it maybe later. Okay, so right, so the main point here is to understand, okay, can someone outline for me what parts of this code are we seeing for the first time?
The open function.
Right, excellent. And anything else?
Words.text.
Yes. So we have two things. One is a constant string, right? Clearly, because this isn't a variable. So this is, what the file is, and open is what associates the content of this. So remember when we talked about files being blobs in our system, then what we're doing with open is we're simply dumping this into a variable now. Some variable. In our case, it is succinctly called file, right? So this is a very high level understanding of what we're doing with this. And since it's already in our PDF, it is perfectly okay to copy paste it. So that's what we're going to do. You guys remember random choice, right? So does someone else want to write this part of this code? Just import random and copy paste this line. Oh, I see it's already important random. Okay, yeah. Oh, yes. What kind of loop is for line in file?
For each.
Right. So, and what is the content? Like, what is a line? Like, what is it doing? How is it accessing it, and where is it going? What are the, you know?
Would that be
Okay.
the index? The line would be like an index?
Yep, it is like an index. Let me put this way. If you didn't use the for each loop, let's actually, yeah, let's talk more coding, right? First, let's see what happens when we just do this, right? And it's up. Ah, fantastic. Because apparently it's called CS words. Okay, so we got a bunch of words. So now the question is, let's start inspecting what happens without these for loops, right? Okay, this is interesting. So this is telling us certain things. For one thing, mode is by definition, it'll either be read or it'll be write or it'll be both in terms of RW, okay? The other thing is encoding, and we actually discussed this just a while ago when I was talking about how you can imagine the encoding to be like a special signature of different file types. Text files and things which the terminal reads. So by default, although there are terminals which do otherwise, when you read something and it displays correctly in the terminal, then it's probably going to be formatted as text. And UTF-8 is a very popular text formatting. You might also have heard of ASCII, ASCII, which is another text encoding. But that's about it. And it is a special kind of thing called a wrapper. Now, what can we do with this? Can we do anything with this? Can we do fun things with it? Can we query it? Let's find out. Clearly, we can't. Okay, great.
What would happen if you print type file? What's the type?
Ah, that's a good question. I suspect it'll actually be the same output because I think the default when it doesn't know what else to do, yeah. So you see, the class is this IO wrapper, and then it is an IO wrapper with these properties. That is when it reads it in. So this is sort of like saying when we start working with these pixel objects, for example, right, then we give it an image as well. So similarly, before that, these are pixel objects, but they don't have any data associated with them. So similarly, we have now associated name, mode, and encoding with our file type object, right? Now, it so happens that when dealing with files, you do almost always have to use a for each loop. The reasons behind this is because, okay, let's not put it that way. Let's do some introspection on what line is. So by the way, we may have noticed that we don't have strip. I mean, we've never seen strip before, right? So let's actually do this without strip, see what that does. What do you guys think it does?
Removes the extra space.
Yep, sure looks like it. So let's try to take a look at this file. Okay, so what is this file? So you see, although this editor does not show you that, well, it does if you do this kind of selection. There's actually a new line here, which in UTF-8 is causing it to produce this kind of code without strip. And with strip, which is this very nice function, which, you know, as you mentioned, gets rid of extra space, we just, you know, get back the lines we want. So yeah. So this is
quick
fun.
question. sorry, a quick question on the for each. Though the word line, that could be replaced with anything else,
Oh yeah,
right?
absolutely.
And that's for any for each, we can choose what to say. It's like what last week for pixel, we used ix, and it was the same no matter what.
Mm-hmm.
Okay.
So
Thanks.
the concept, that's actually an excellent point to raise, and the reason why that happens is when we deal with these in this kind of a situation, we're really looking at, so we can imagine, so this was our image, this week it's called file, right? This is basically some class, some large object, a list, if you will, which contains other objects, right? These guys, pixels. And when we do a for each loop, we did quite a bit of discussion on this last week. Remember when we talked about if you know when to stop, then you shouldn't be using a for loop, maybe for each loop, right? I mean, a for each loop will go from beginning to end, right? So for each loop goes down this entire collection. So internally, what it does is that it just says, I will go over all these objects in this collection. And it doesn't really matter what you call it at that point, right? But if you remember with pixels, we could do that because the other kind of object, that was a list, by the way. Because that was a list, we could actually index them. Remember, we were able to write code, which we can't do with a file, with a default file, to be clear. We were doing things like this. Do you remember? And in that case, in that case, we could like have more fine-grained control. But okay, so
Okay.
fantastic. Now, one question which should arise naturally is, what is this then? What is it that is happening? And it turns out they are all strings. Well, that makes sense. I expect them to all be strings. Okay, note that running this function of a string is the same, right? It'll return a string because, you know, string in, string out. Right, so we're all back? Yeah, okay, fantastic. So let us, let's share the screen again. Okay, everyone can see the screen? Fantastic. Right, so what we were talking about is that, so this strip function is an inherent function which is defined in the class of string. And, you know, actually, especially since Charlie missed out last time, I think it might be instructive to take a look at simple image again, because that was actually simple. So if you recall, we defined a pixel class there, remember? And we gave it certain properties, and more than that, we gave it certain functions. And we kept calling those functions, right? So this is basically, you know, kind of like calling the function. And we were able to, so this is a function of image, and here it's simpler because we can take a look at what that is. So yeah, I mean, that's the general concept which we're trying to go for. Back to week 5. Okay, right. Now, I should actually ask, do you guys want to play this game? Or should we move on to, like, to be fair, we could code these out, but in the interest of time, should we come back to this? I mean, is there anything about these 3 milestones that you're worried about?
No, this looks pretty doable.
I personally before I even get to this, I'm still hoping to be able to finish
Ooh,
assignment.
wait, I have a problem. I can't hear you. Abraham, I can't hear you. And Sean, I don't know if I can hear you. Can you say something? I don't think I can hear anyone. Oh my God.
Can you hear me now?
Damn it, why do
I can hear
I
Abraham.
extra?
Do you want us to type?
Ah, there we go. Okay, right. Now can you guys speak again? Should work.
Hey,
Yeah, perfect. Right.
Can you hear me now?
Thumbs up, but I forgot that you guys can't see me. So these milestones are cool with everyone?
Can you hear me now?
Yeah, I mean, these three.
Yeah, they look doable to me, personally.
Abraham,
I'm okay to go over them though.
Abraham, Charlie.
And I will have to go over them. I will have to go over them too because right now.
Okay, let's do that. Right. So this is basically putting together some of the things that we know already, right? So what does the milestone say? It wants us, so let's start writing pseudocode. Let's begin with that. So we have to load the words. We have, so what are the two parts of loading the words? Let's split this up a little bit. Week 5. You guys should all have access, but if you guys could hop on here and we'll just quickly write some pseudocode. Where's the chat? Ah, there we go, chat. Oh, no, now I can hear you. So it's chill. We don't need to go back to the chat. And that was completely useless. This is the working link, yeah. So let's start with what we have to do. We want to be able to load a file. So what are the steps? How do
Do you
we
want to read all the files first, like all the words in the file?
read? Okay. So before that, what do we know how to do already? I'm just going to close this one now. What do we know how to do already? We are clearly able to print out all the words. So in another sense, we have a handle to access all the elements, right? But that's not enough. It says load them into a list. So I know we kind of hurried through this, but how might we do this? What is the general idea?
So when we use the open function and assign that to a variable, does that change the type to a list?
Very good question. And so you're asking about the type of file?
Exactly, yeah.
Right. Let's find out. No, it's not automatically a list because the open function does something very special. And in fact, that's why, if you remember so it's not a list because, okay, now this is actually a great point to raise because the question is, why isn't it a list? Because clearly for text, a list makes sense, right? The reason
Yeah, and also how is the for each even working if it's
right.
not a list? All right, yeah.
So the for each basically, and this, so a similar question, or rather an interesting question related to that is, did I close this? Ah, yeah, here we go. How is this for each working last time? How is the IX loop working? because clearly these were not text either. These were some kind of object. Which brings us to a concept of what the for each does, or what does it look like? What does the word look like to a for each loop? Okay, so to a for each loop, you just have all of these things. You have a list and it'll go through that list, right? But if you remember a few steps ago, we discussed and we saw that a list can contain multiple different types, right? A list can contain anything, really. So what that means is that the for each, okay, there are a couple of ways to break this down, and this is a very important concept. So let's do this bit by bit. So let's first start with a little list. Okay. X is a list, right? Now, X is a list, and things in X are, either a list or a float or whatever, or an int, what have you. So, and what is a list? A list is just a special kind of object, right? Which has its own internally defined functions. In this case, the most important one we've done until now is append, but there are others. We don't care, right? Now, the for each loop will take a collection of objects. Okay, so when we're doing for value in X, print X, okay, I always forget, but that the default Python interpreter for some reason does not do this for you, even though it really should. So for value and value, my mistake, print value. Right, so this is the core concept right here. We're saying that X is some collection of objects, right? And the for each loop will go over each one of these objects. It'll take, and now importantly, now let's do something a little bit more fun. 3, 4, 5, or 2, 4, 5, whatever I'm typing. Z is equal to, let's talk about this. So first of all, we see that, okay, what is happening here?
It's a list of lists.
Fantastic. It is a list of lists. So now how do we work with this list of lists? Do you think, yeah, so clearly because we recognize that it's just a list of lists, these are lists. But a more fun thing is that we can actually, hopefully, let's find out, do this. Now, the question is, which list got 6 appended to it? And what is the difference between what we did and this? We can actually just immediately see the result by checking Z, but this is a conceptual point. Where is 6 and where is 7?
Is 6 at the end of the first list within the list?
Mm-hmm. Abraham, Charlie, do you guys agree?
I think yes.
Okay. This is surprisingly blurry. Damn it. It's fine. Is this? Okay, let's do it again. X is something. Oh, let's just get back to good old 30. What about 7? What happened to 7?
New element.
Right. So this is fantastic because this means Python doesn't give a damn about what's in the list, right? I mean, it really couldn't care less. And because it couldn't care less, when we run a for each loop, again, it really doesn't care what kind of value it's looking at or what is going on in there, right? It'll just print. Oh yeah, sorry, because so okay, yeah, no, wait, we didn't discuss this. What will happen now? So to
It'll
make
it'll, it'll print each element.
okay, so we have one option of it printing each element, right? That's a very good option. But what is an element in this list?
Strings and integers,
Mm,
because
not
the first two has like the quotation marks.
okay. Yes, I can see where that would come from. But how did we define this? If you go up, we just defined z to be x, y, and then later we appended 7 to it, right? So that means that, you know, what we're really looking at is here. And although the whatever this guy is pretty great, it's sometimes easier to just show here. So that means when we loop over for each, the elements of the list which it thinks z has is not, so we might know that this is some set of integers and floats and all of that, right? But that's not what the outer for loop is about. The outer for loop is about z. And what does z have? Z has, you know, z0 is equal to x, not 2, 3, 4, 6, but a list. Is that like, and this is, it's not a trivial concept. This is the basis of why Python is easy, and it is also why Python throws the most incredible errors sometimes.
Is
So,
it similar to last week with like the individual pixels in the cluster or the collection of pixels?
yep, it is exactly like that. That's great catch. So what's going on here is, see, does this clear the concept which I was talking about? So it shows, so to the outer for each loop, it is going over 3 objects, right? One is x, one is y, and one is 7. And that's all the for each loop cares about. It just cares that there's a collection of some other kind of object in there, right? So for the for each, you know, I'm just going to close this thing. Somehow I'm not very comfortable working with slides here anyway. So yeah, let's just, to the for each loop, the only thing which matters is that there must be things it'll go over. As long as your for each loop is given something which is indexed. I always forget whether Python starts from 0, so it does, or whatever, okay. The only thing which matters is that you should have these indices, and it will go over each of these. What is inside object? Anything. For each does not care. And so similarly, the index which we assign, you know, when we do for x in blah, then x can become anything, including when we work with the file, what does it become? So let's talk about that again. What is happening to this? Let's go back to this guy. Clearly, we're able to extract this information, right? So, you know, forget about strip for now. It's just an operation on a list, which returns, I mean, it's an operation on a string, which returns another string. So when we talk about things, we're just going to call it a string, right? So here, file is a collection. So in fact, yeah, let's do this. Can someone or everyone draw what file is represented in to the for each loop? Like, what does it look like? It's some sort of container with some kind of objects in it. But because we've already done so much playing around with it, we know what kind of objects it is, right? So this is file, which we read in and we understand to be simply a blob in the system memory, right? The system ROM, if you will, on your hard disk. So this was on your hard disk, this bunch of zeros and ones that got dumped into file, which we saw is that weird IO wrapper, right? So we saw that file is some kind of IO wrapper. Okay, so a quick aside into why it's IO wrapper and why we're not able to query directly is because no one told us that file is going to be fantastic. Yes, this is perfectly right. It consists of string objects, right? Is that clear to everyone? Because we just saw it. Okay, now wait, there is still something going on, and to show that, I would like to actually, let's see. Okay, let's work with this. Now this is going to break the program, but that's good. You know, when you're learning, it's good to break things. If you're not breaking things, then you're clearly not being adventurous. Okay. What do you guys think will happen? Will this work? Can this work? And yeah, thoughts, ideas, hopes. So before that, let's see if we can actually get a representation of a PDF file. Evidently not, right? So what should, let's do this one by one. Any ideas what type file will give us? Let's give it a shot.
Is it the same as the .txt?
Yes, it is. And now let that sink in for a second. And this is the reason why everything else goes on. It is the same kind. Okay, that's great. But what about when we do this? Remember previously we were getting some information. We were saying, no, it's UTF-8, it is mode R, you know, read only, blah, blah. What about this? Let's take a look. Right, and this is why we're going to run into more trouble. For one thing, we see that to the Python program, it still believes it is some kind of, you know, UTF encoded text file. We know this is untrue, right? So then what will happen when we try to do this? Right. So this is fun because like this is a fun error. Clearly these are not UTF encoded, right? And that's all the Python program is telling you. It's saying, what is wrong with you? This is not a UTF encoded file. This codec, this reader cannot read this kind of bytes, this kind of memory, right? This kind of data. Right. So, but again, this is kind of digressing, right? The truth is, there's a lot going on when you run this function. Well, I mean, not a lot, but at least two things are happening. You are making assertions about what you're looking at. And the assertion you're making is that you're looking at a file. And more than that, you're looking at a text file. Now, these are things which Python is expecting, which is why when you start to work with this, right, for X in file, it wants a string. It will not accept anything else. You can't change it to an image or anything without changing this open file. Because if you remember last time, we had to use a separate function, simpleImage.load. Remember, there was some simple image load or something like that, which we were using to read in the image. And the whole reason is because of this, because open does some expectations in the background. It enforces certain things. But that actually doesn't even answer what you were asking, right? The question was, but yeah, I mean, I want to know if this helped at all. With this understanding, is there any reason you can think of why we shouldn't just, why Python doesn't just expect a list? Like, why have this intermediate step of, you know, whatever this is, right? I mean, this entire class. Why have this? Like, what's the point? Clearly, it's not able to do anything but text. And equally clearly, if we really want to work with text, then don't we need to put it in a list? Don't we need to subscribe to it? Like, what is going on? Why does Python do this for us? Okay, so to answer that, I wonder if they have this. To answer that, let's see this. Okay, so this is the size of the cswords.txt file. It is tiny, right? I mean, it's 4 bytes or bits or whatever DU does by default. I can't remember, it doesn't matter. But the size matters because while it's true that it is only taking in text files, we still have a finite amount of memory. So if I want to read in, say, for example, the entire works of Shakespeare in text form, right, that's clearly going to be a lot more words. And often it's a lot more words than we even care about. So suppose you download a Wikipedia corpus, right? You download a bunch of Wikipedia pages in text format, but you only care about one page. So when you read it in, it doesn't help you to automatically assign. Okay, so this is your memory, right? And you can fill this memory with different objects until it gets over, right? And then you get some kind of buffer overflow or whatever, sad frog. What's happening here is this wrapper function, this function here, this IO, where to go? This one. This allows us to represent this in a more efficient manner. Okay, what that means is, to not get into this too much, there are different. Okay, let's recall. This is an integer. This is a string. Is it intuitively clear that this takes more space than this, right? But there are, like, we are now familiar also with the idea of encodings, which is to say a PDF file might look like, you know, whatever, some junk values, right? Now it looks like junk, but this actually is a form of encoding or a form of compression. So the real reason why we have this IO wrapper is we're basically saying, okay, it might be a large file and I don't want to read in all of it at once. So what happens is when you start going over this with the file, with the for each loop, when you start saying, I know you're a bunch of objects, right? And because you've opened it with an IO wrapper, then you're saying, I know you're a collection of strings. Show me those strings. So the point is, what's happening is that at this point, right, this is represented in IO wrapper format. Okay, I know we just called this a PDF, but I don't want to write more junk here. So if this is the representation of that IO wrapper object, right? When we call this, when we actually use the for each loop, then it's becoming, in a sense, like it's expanding into these bunches of strings. Is that somewhat clear?
Yeah, so it's only doing that once we do the for each.
Yes. So the idea is when we read in a file, then, and this is a kind of sane approximation, right? Because we don't know how large that file is. And it kind of sucks if your program crashes just because you're reading in a file. The program should crash, but only when you do something with the file. And so that level of, you know, indirection is what is happening here, right? So, okay, that aside. So we're actually close to the end of this. I mean, the entire, or are we? Can someone tell me how we would load this into a list? We know that X is a string, and now we just need to make a string, make a list out of this. How would we do this?
Maybe I could try.
Sure. Yep, fantastic. That is absolutely right. So that's milestone 1, actually. Load all of these guys into a list. Excellent. So we've done milestone 1, but more importantly, we also covered the understanding of, you know, what that IO wrapper is. Yeah, I love how every one of these milestones actually brings up a good discussion of a real concept, which is important. That's, I mean, it's one of the things that's like, even the things which I think are not that important, Okay, show a randomly chosen word from the list. Right, this might sound familiar to everyone. What does it sound like? We may have done this before. We have random. We would like to randomly choose one. And in the interest of time, we can, if you recall, in fact, we don't even need to do this time. We can just use random.choice. Do you guys remember random.choice? I believe it was random.choice. And this takes my sentences, which is now complete. So random word is equal to this. Print. Is this clear why this is working? Oh, yes, of course. So that's milestone 2. Does anyone have any doubts about milestone 2? Show a randomly chosen word from the list. Thankfully, we didn't have to actually write any code. We just called a library function, right? That's, Milestone 3. What is the last milestone? Repeat. Wait for the user to hit enter, then show another word. This is a much simpler problem than the Stroop effect, which I know you guys are brilliant at. So would someone like to take a stab at it? We just need to make sure that this continues.
Is it basically you have to wait for user input?
Yeah. So we basically want to run this again and wait for user input. So let's take another look at that. We need to wait for user to hit enter, then show another word, which we understand is just, it's very much like the Stroop effect, only way simpler in the sense that in the Stroop effect, we were showing the user input and then also checking and keeping count of what was going on with that input. Here, we're simply waiting for them to press enter, and then we're just showing the other word. Quick context, actually, it turns out many of the other students were not happy with the Stroop effect, and moreover, many of the section leaders thought the Stroop effect problem was too hard. So I think they didn't teach Stroop effect, and that's why it kind of got shifted here. But yeah. Does anyone want to take a stab at this, or like? Okay, yeah, well, we can still use this. What kind of loop should we use? While for? Hopefully we finish this in 10 minutes, and the next session, I mean the last session for today maybe, will just be discussing the last problem of data science, quote unquote, and yeah, future projects. So let's do this in 10 minutes. What kind of loop? For each while?
While
Okay, why?
we essentially want to keep going while the user is giving us an input, and then once they stop, we want to stop.
Excellent. Anyone else has any comments, ideas why that shouldn't be?
I agree with Sean.
Fantastic. Okay, so clearly this is right. I seem to have run into an error. What is my error and how do I fix this? Okay, first of all, what is my error?
You have a continuous loop.
Okay, yeah, that's one error. But even before that, we seem to have run into a fundamental problem, which is that We want to show a random word, but we're showing the same word, right?
Oh. Mhm.
So, although it is true it's an infinite loop, but the reason behind that is because the milestone does not actually tell you how to quit, because again, it's a deeply simplified stupefect. But anyway, forget that. How do we fix this? Because this is a real error which we really need to be worried about. Why are we getting the same word? And not just the same word, we're always seeing Carol. That is horrifying. Why is this happening to us?
The while loop is within the for.
Ah, yes, indentation. So it so happens that I personally believe 9 times out of 10, when you see a Python error, it is going to be indentation if you're not using an IDE. If you're actually programming Python in a text file or whatever, 9 times out of 10, it will be some kind of indentation error. And you can bet your life on that. Okay, so we have solved this. Now, about the infinite loop. Oh, by the way, everyone remembers when we first started talking about variables, how we did, we can just give it a value or we can give it a condition, right? We talked about how, and we did this because we didn't want to, we were trying to understand the control flow, like how different things go, the different actions of the program, right? Okay, now here's the thing. We have solved this entire thing. Do you guys want to play this? It's a game, and the game says that so as each word shows up, then two of you will close your eyes, and then other people will prompt you, but not by saying the word, and the person has to guess what word you're talking about. Okay, right, excellent. I mean, not excellent. I mean, I'm always up for a good game, but yeah, okay. So that was that. As I mentioned in the original announcement, we have thankfully, or rather, thanks to you guys being awesome, we did complete the initial thing. So this one, wasn't that much of a deal. Okay. Right. What to say about?
So I'm leaving.
Okay, sure. Did you understand this problem? Did you like it? I mean,
Oh yeah, I understood it. I'll just have to catch it later, and this is why will you upload the videos on?
Oh yes, absolutely. In fact, if you check the mailing list every time, I mean, so yeah, let me just show that to you, and then you can leave. God damn it. It's time. Right. So here, all of these, whenever you see these meetings, so the ones which are tagged as meetings have the video links.
Okay.
Well, and in fact, there's actually a playlist. I think, yeah, you can access that. Sadly, the Stroop effect one is missing, even though that was like super awesome. I unfortunately lost that. Damn. Okay, I think I didn't make a playlist because we're not supposed to publicize these yet. So these are all like unlisted, I believe. So yeah, you'll have to, if you just search for meeting, then you will see, meeting 1 has the recording here. So similarly, and then there's 2 and 3, but sadly this video doesn't. Yeah, this video does not work, but there is a workspace, and the workspace has all the code, and it's tough. It was not a trivial problem, but it's really cool, and I suggest you take your time to work through it. These are all associated with our fantastic docs here, right? So, and yeah, I mean, I'm always open to questions, so you can like let me know whenever. It was really great to have you in this class, and if you'd like to present, I'd be super happy. I'll be sending an announcement later, right? And yeah, thanks so much. See ya.
Thank you very much, guys. See you again.
Yeah. Okay. Now, we're probably going to get thrown out of Zoom in a couple of minutes, but that's okay. We'll come back. Now the idea is, first of all, thank you guys for staying for so long. I hope it's okay to stay a little bit longer.
When the time is up, I have to go to. I'm in a public building, and they close at 4:30.
Oh boy. Okay. Well, thanks for showing up. Okay, then I just wanted to talk very quickly, not about this. So first of all, a little bit of a rant. I don't think we should be covering, especially a problem like this, because it is not a nice problem to cover, and I don't have time to talk about statistics, nor am I supposed to talk about statistics. But clearly, summary statistics like counting non-zero values and all is not a very useful thing. Um, I mean, for so many reasons, there's a whole statistics course, there's epidemiology, there's just so many other things to do with virus data, and there's so many nicer problems to take. But really, what I want to talk about in the last couple of minutes then is, what is the point of today's class? Because you may have thought, and to be fair, it was a little light, but the main idea which you should take away is that files are first class blocks of memory. Everything is a block of memory, okay, of some kind. And you can put it in your program using different functions. Like by now we've seen two, right? We've seen open and we've seen, whatever simple image had, right? Why is this a powerful idea? This is a super powerful idea because now you can query anything with this understanding. Now, there's no real reason why this file object has to be on your computer. It can be on someone else's computer. You can transmit this over the internet. So the concept we're trying to get at is APIs, or application protocol interfaces. So once you accept everything as a file and everything as a chunk of data, then your ability to manipulate that data is then only covered or broken down by your inventiveness, right? Because so we know that there are higher level concepts which happen under the hood, like this gets encoded into a different kind of thing and this expands. But really, the key takeaway here is that, and this is something which, if you're not working on a Linux machine, you will have trouble with, right? Because files seem different, files seem magical. On, say, Windows, you can't even open some kinds of files. Not so on Linux. You can try to open anything because they're all just data. Hey, yeah, so I think I'm not sure if Abraham's coming back, but so are you?
Yeah.
What are you planning to work on for your final thing? Would you like to present next week?
Yeah, I definitely would like to. Yeah, I'll tell you about something, but just your point there, because you got cut off. So we can import anything to Python and kind of like use it in our code. That was kind of the main takeaway.
Yeah, so the main takeaway is that as long as okay, now it's a little bit more complicated in the sense that, as you saw, just trying to use open doesn't work, but the concept remains the same. So when you want to use a web something or the other, right, then you'll use, say, a different library. Popular one is called Beautiful Soup or whatever, the names don't matter, the concept matters. It is possible to view it as a representation of data, and to take it into Python, all you need to do is write the right kind of function which will convert it to data which you can use. So you take any arbitrary object anywhere and you produce out of that a set of objects, right? So you make classes. You make a class. So that's precisely what we did when we did with images, right? So we wanted to read images in, and moreover, we wanted to view them as a class of pixels. So then we made a class called pixels. This is the idea. You can take data, structure it into an object, and then work with that. Go crazy with that.
Yeah. Okay. I think last week, thanks for, like talking about it so much, but I was having trouble kind of understanding that. like the whole objects and what that was exactly. And like the way you described it was a template where we can pretty much use it over and over again.
Yeah.
So it's like we would take a data set and then we would have these objects, and then that we can fill those objects with the data. Is that kind of the right way of looking at it?
That's exactly right. And in fact, once you accept that, then everything else becomes the same. So even when you do machine learning with huge data sets like 500 GB big, what all they're doing is and in fact, a lot of data science is just making sure your data looks the way it can so that it fits into a class object. It is breaking it down to that form. So when you deal with hardware, like specialized hardware, like GPUs, then there are certain constraints, additional constraints, like it can only accept data in batches of this size. So then your job is to then break up your data into those kind of formats, into those kind of containers, basically.
Yeah. Okay. That's super helpful because I wanted to look at there on the California.gov. There's all these data sets for just public information, and I want to kind of look at things like whether it be water or transportation or any natural resources. I want to see how things have changed in the time of coronavirus. But I feel like I need.
So
I want to.
The library which you need to work with that kind of data is called Pandas.
Okay.
And I'm not sure if I have a good sample of what is considered to be a good Pandas book. Honestly, so one of the other things which I wanted to focus on, I hope it came across, is that realistically, the documentation on these websites of these actual libraries is always very good. And Chris and the team have also done a fantastic job of trying to make that clear. Like 9 times out of 10, your problem is solved by reading the section, right? Like even today, we knew to use open because it was in the section guidelines, right? Similarly, like there are many tutorials out there, but I would say go to the actual project page, just pandas.pydata.org, and work through these, because these are coming straight from the source. These guys want you to know how to do it. They're not trying to sell you a book. They're not trying to sell you a lecture. They just want you to use their library. So yeah, I mean, that would be my suggestion. I think it's fantastic. And they have these nice little graphics and everything. So
yeah, that is fantastic. Thank you for, I really do appreciate all the extra kind of high level ideas that you've been going over. Because, from the lectures that we're watching with Chris and Maran, it's really easy to just, follow, okay, here's what a function, here's what they're doing. But kind of understanding what's going on under the hood has been really helpful. So I appreciate that. So thank you.
I'm so glad it helped. Thanks a lot. This was really amazing. And I can't wait to see your project next week. Yeah. All right. Thank you. And if I ever have a question, can I send you a message through Ed? And just, I think there's a private message system, I think. I haven't used it. Yep, you can do that. And for that matter, you could also, I'll just drop my email ID. Yeah, I mean, if you want. But yeah, I'll keep up with the Ed as well. Or maybe personal one is better. Okay, awesome. Yeah, that'd be really helpful because I do appreciate, you clarifying things. Sure. I mean, it's it's been really great. Thanks a lot. Yeah. I'll see you next week. And yeah, I mean, it would also be nice if you show up for the AM one. But yeah, I'll keep up with the Ed as well. Or maybe personal one is better. Okay, awesome. Yeah, that'd be really helpful because I do appreciate you clarifying things. Sure. I mean, it's it's been really great. Thanks a lot. Yeah. I'll see you next week. And yeah, I mean, it would also be nice if you show up for the AMAs because some of them will be good. I mean, not gonna say anything about the other section leaders, but yeah, some of them will definitely be great. And yeah, I look forward to seeing you around. Bye. Yeah, bye. Thank you very much. Talk to you soon. Yep. See ya.